Have you ever pondered why we measure software? Why do we bother with metrics and data? Well, just as a tailor measures before cutting a suit, we measure software to ensure the best fit for its purpose. Software measurement is a way of quantifying the attributes of software products, processes, and resources. It's like a health checkup for your software, helping you assess its quality, efficiency, and effectiveness. Imagine you're building a skyscraper. Without measurements, how would you know if the structure is robust, or if you're using resources efficiently? Similarly, in the world of software, we need to quantify various aspects to ensure we're on the right track. Software measurement allows us to identify areas of improvement, make informed decisions, and ultimately improve the software that we're developing. It's like having a roadmap, guiding us on our journey of software development and helping us navigate the complex landscape of code, efficiency, resources, and quality. So, software measurement is not just about numbers, it's about making informed decisions and driving improvements. Let's dive into the world of metrics. In the realm of software, metrics are our quantitative measures. They are the yardsticks we use to assess various aspects of software products, processes, and projects. These can range from the complexity of code to the efficiency of our development process. Just as there are many facets to software, there are many types of metrics we can utilize. Product metrics, for instance, assess the attributes of a software product. This could be the size of the code, the complexity of its structure, or even how maintainable it is. Then we have process metrics. As the name suggests, these focus on the software development process itself. We can look at the effort required, productivity rates, or even the time taken to rectify defects. The third type is project metrics. These provide a snapshot of the project's health, offering insights into areas like schedule variance or cost performance. Now, it's important to note that not all metrics are created equal. They rely on different measurement scales. On one end of the spectrum, we have nominal scales that classify data into categories. Then there are ordinal scales, which go a step further by ranking these categories. Interval scales, on the other hand, allow us to measure the distance between categories. Lastly, we have ratio scales, which add a meaningful 0 point to the mix, allowing us to make statements about ratios. But remember, selecting the right metric is not a game of eeny, meeny, miny, mo. It's a deliberate process that should be guided by your measurement objectives. A metric that's perfect for gauging code complexity may not be the best choice for assessing productivity. So the next time you're faced with a sea of data, remember to choose your metrics wisely. Don't simply reach for the most accessible or familiar one. Take a moment to consider the objective of your measurement, then select the metric that best aligns with that goal. Remember, the right metric can provide valuable insights, but the wrong one can lead you astray. Measurement is not just about collecting data, it's a process. This statement holds especially true when we delve into the realm of software measurement. Imagine software measurement as a journey. The first step in this journey is defining your measurement objectives. What are you trying to achieve? Are you aiming to improve software quality, enhance efficiency, or perhaps assess the effectiveness of your development process? Your objectives will guide your selection of metrics, ensuring that you're measuring what truly matters. Next, you select the appropriate metrics. Now, this might sound like an easy task, but it's not. With a plethora of metrics available, ranging from product metrics like size and complexity to process metrics such as effort and productivity, it's essential to choose those that align with your objectives. Remember, each metric provides a different lens through which to view your software, and the wrong lens can distort your perception. Once you've chosen your metrics, it's time to collect data. This is where measurement tools come into play. These software tools and techniques automate data collection, significantly reducing the time and effort involved. They're like your trusty sidekicks, always ready to dive into the depths of your software and retrieve the data you need. After data collection comes analysis. This is where you transform raw data into meaningful insights. Whether it's identifying patterns, spotting anomalies, or calculating averages, the analysis stage is all about making sense of the data. And again, measurement tools prove invaluable, providing automated analysis capabilities and visual representations that aid understanding. The final step is using your insights to make informed decisions. This could mean adjusting your development process, reprioritizing tasks, or investing in additional resources. Whatever the decision, it's driven by data, not guesswork. Throughout this process, it's vital to remember that measurement is not a one-time event, it's an ongoing activity, integral to the software development lifecycle. Regular measurement enables you to monitor progress, track changes, and respond swiftly to emerging trends or issues. By following a systematic measurement process, you can ensure that your data is reliable, relevant, and actionable. And ultimately, that's what software measurement is all about. Empowering you to make data-driven decisions that enhance your software's quality, efficiency, and effectiveness. Size and complexity matter when it comes to software. Imagine you're shopping for a new car. The size of the car matters, right? You'd look at the number of seats, the size of the trunk, the overall dimensions. Similarly, in software, we measure size in various ways. The simplest way is by counting the number of lines of code or lock. It's like measuring the length of a road in miles or kilometers. But lines of code don't tell you about the functionality or complexity of the software. It's like knowing the length of a road, but not knowing if it's a smooth highway or a bumpy off-road trail. That's where other measures come in, like function points or FP. FP measures the functional size based on user requirements, inputs, outputs, queries, files, interfaces, and so forth. It's like assessing a car based on its features, power windows, air conditioning, sunroof, and so on. But FP doesn't consider the complexity or the object-oriented nature of modern software. For that, we have object points or OP, which measure size based on the number and complexity of objects or components. It's like evaluating a car based on its mechanical components, engine, transmission, brakes, etc. And then there's use case points or UCP. UCP measures the size based on the number and complexity of use cases, which are essentially user interactions with the system. It's like considering how the car will be used. City driving, off-roading, long-distance travel, and so on. Now let's talk about complexity. Cyclomatic complexity measures the complexity of software code based on the number of linearly independent paths through a program. It's like assessing a road network based on the number of possible routes from point A to point B. Halstead complexity measures quantify software complexity based on operators, operands, and other factors. It's like measuring the complexity of a car's electrical system. And McCabe's complexity evaluates software complexity by counting the number of control flow structures, like loops and conditionals. It's like evaluating a car's performance based on its handling and maneuverability. Whether it's lines of code or function points, each measure provides a different perspective on software size and complexity. Quality is more than just a buzzword in software development. It's the cornerstone of a product that not only works but works well. It's the difference between a software that's simply operational and one that's reliable, efficient, and a joy to use. This is where quality measurement comes into play. There are various metrics we can use to quantify quality. One of the most commonly employed is defect density. This measures the number of defects per unit of software size or effort. It provides a clear, quantifiable measure of how bug-free our software is. Next, we have fault removal efficiency. This metric gauges the effectiveness of our defect detection and removal activities. It's not just about finding the bugs, but how efficiently we can squash them. This helps us refine our debugging processes and improve software reliability over time. And then there's code coverage. This measures the percentage of code exercised by tests, covering aspects like statement coverage, branch coverage, and path coverage. It helps us evaluate how thoroughly our tests are examining the software. A high code coverage means our tests are comprehensive, reducing the risk of undetected bugs slipping into the final product. Each of these metrics plays a crucial role in ensuring the quality of our software. They provide tangible targets and ongoing feedback, guiding our efforts towards creating a product that not only meets but exceeds expectations. Quality measurement helps us strive for excellence, not just adequacy, in software development. Effort and productivity are key considerations in software development. Estimating effort is like predicting the future. It's about anticipating how much work will be needed to complete a project. This is often done using historical data and expert judgment. But remember, it's an educated guess, not a crystal ball. On the other hand, productivity measurement is about efficiency. It's looking at how much value we're getting out of the work we put in. Metrics like lines of code per hour or function points per person month come into play here. However, it's important not to oversimplify. Productivity isn't just about speed but also quality. So, story points per sprint might be a better reflection of a team's real productivity. These metrics can be game changers. They help optimize resource allocation, improve project management, and ultimately, deliver better software. Effort and productivity measurement can turn chaos into order in software development projects. Measurement is not an end in itself, but a means to an end. It's the fuel that drives process improvement in software development. Benchmarking allows us to compare our performance against industry standards, while root cause analysis aids in pinpointing the origins of issues. Crucially, continuous measurement fosters a culture of constant enhancement, keeping us on our toes. By harnessing the power of measurement, we can transform software development from an art into a science.